What we do is a platform-based product. It might be a bit like Airbnb or DD Shuxing. We might be the Airbnb of the computing power world. Our research in AI has also found that the precision requirements for the inference of large AI models are actually decreasing. It might be from, for example, double precision floating point numbers down to single precision, and now even down to FP4 or N4, and they can still run very well. Why is it that China has a lot of open source, while in foreign countries, North America is now mostly trending towards closed source? I think it's probably because everyone's business models are not that similar.
Stephen Data Talk.
Stephen Data Talk. Hello, everyone. Welcome back to my podcast, Stephen Data Talk. Today, I'm very honored to invite Adam, the co-founder of Gongji Computing Power, to share with us. First, Adam, could you briefly introduce how Gongji Computing Power was initially born, the background of the founding team, what pain points you saw in computing power at the time, and why you founded this company?
Okay. Thank you very much for Stephen's invitation. Hello, everyone. I'm Adam, the co-founder of Gongji Computing Power. Gongji Computing Power is actually a startup from China. How do we get started? It was actually in 2023. At that time, we were all amazed by the explosion of GPT. We found that at the same time, GPU computing power had become a precious strategic resource. So we commercialized some of the projects related to computing power scheduling that we had done previously at Tsinghua University and established this startup. The founding team is mainly composed of 3 of us who were PhD students from Tsinghua, along with several other partners from the industry with rich engineering and business experience. Together, we started this company. At that time, when we were at Tsinghua, we had already tried to build a computing power sharing platform ourselves. It wasn't for providing computing power for AI, but because several of us were PhDs in mathematical and physical sciences, some doing engineering. Sometimes in order to publish papers, we would encounter a lack of our own computing resources. Researchers often start writing papers only when top conferences or major meetings are about to begin and deadlines are approaching, so time is generally not enough. And when we start writing papers, we need to do a lot of computational simulations, and these simulations cannot be supported by our own computers or the lab's computers. But we were very anxious, so what could we do? So in the beginning, we made a very old and simple platform. It was called a computing power trading or sharing platform. We asked other people in the university to connect their computers when they weren't using them to help us calculate some scientific research problems. And this attempt was actually quite successful. At that time, we could calculate some relatively difficult problems with up to thousands of nodes like quantum many-body simulations and dynamics. After that, we realized that this platform was something that no one had done before. And this kind of project seemed very suitable for the new wave in the context of computing power as a factor of production. So we took the funding from Miracle Plus, which is China's YC, and started. We got their seed funding and we set off. We started our project, right? Then at this time, AI also had an explosion, and the United States would impose an export ban on some relatively high-end GPUs to China. So at this time, we felt that our platform was even more valuable. We could shift the story from just sharing computing power in the research community to a larger context. From a macro perspective, we can take the computing power resources in the hands of both individuals and enterprises to serve the most important production tool of the future, which is AI. Therefore, the imaginative potential of this story suddenly became much larger. We have also been exploring in this direction for about 2 to 3 years.
Thank you very much for your sharing. So, the problem Gongji Computing Power solves is essentially the problem of computing power, to put it simply. So, in the subcategory of AI infrastructure, within the AI industry, the competition is actually getting more and more intense. Where will your product's differentiation mainly lie in the future?
Our product model is actually a bit different from ordinary cloud computing vendors or companies that build their own data centers. What we do is a platform-based product. It might be a bit like Airbnb or DD Shuxing. We might be the Airbnb of the computing power world. When your house is empty, you can rent it out to others as a homestay. When your computer or your company's computer is idle, you can certainly rent it out to other companies to perform their tasks. So our differentiation, or our advantages, can be discussed from 2 sides. One side is from the supply side, and the other is based on the demand side. If we look at the demand first, Our current thinking is that as these AI applications gradually grow, the scenarios for computing power will have a shift in proportion. Originally, computing power was used for two scenarios: AI training and AI inference. As AI becomes more powerful and its effects get better, the scenarios where AI applications actually use computing power are all AI inference, and the proportion of AI training will gradually decrease. So, from the beginning, our product focused almost exclusively on AI inference, specifically the inference of large models, and we didn't say we would be heavily involved in AI training on a large scale. AI inference has a characteristic: once it truly becomes an AI application that affects all aspects of social life, it will inevitably have fluctuations and imbalances in terms of time and region. Because whether it's your commute to and from work or some festivals and celebrations, the usage of an AI application will have significant peaks and troughs. In this context, a need naturally arises, which is the elastic computing demand for your AI application. Because when a large number of users, for example, if your AI application is one that helps people with design work during work hours, then perhaps at 10 or 9 in the morning, when designers start working, there will be a sudden influx of users. And if you were to use the long-term, stable, full rental services provided by public cloud vendors or some self-built computing power vendors, you would find that it doesn't make economic sense. Because, for example, you have a long-term lease on a batch of machines, but you can't prepare a batch of machines for the peak. You might lease based on the average value. In that case, there will definitely be times when it exceeds this average value. The computing power for this peak part will definitely require elastic services. And we estimate that by 2030, at least 10 to 20% of the computing power market share will be in the hands of these elastic GPU providers. Therefore, we basically only do this kind of elastic computing power service. And this is on the demand side. Therefore, in terms of product features and characteristics, we will design them to serve a part of the customer's elastic computing power needs to the extreme and to provide the best experience. Then on the supply side, our characteristic is that for those who provide us with supply, whether they are computing power vendors or individuals, we do not require them to make any form of commitment to ensure that they will continuously provide computing power to us. That is to say, people who connect to our platform can go offline from our platform at any time to serve their customers without affecting their original work or life. So we ensure that the computing power vendors and individuals on the supply side earn every penny as extra income. Of course, this also gives us some pricing power because we are indeed doing something equivalent to turning waste into treasure. This is the difference between us and some existing companies on both ends.
Okay, thank you very much for your sharing. There's a sentence on your website that says, "Make computing power as accessible as water and electricity." It seems that with such a product design and resource scheduling, you can indeed achieve this effect. Now let's talk about some technical and algorithmic issues. Is the Gongji scheduling system your secret weapon? And does your computing power allocation rely more on algorithm optimization, resource integration, or hardware management capabilities?
This scheduling system is indeed our secret weapon, at least for the short to medium term, because we're confident that not many people can do it better than us in these few years. Because as I mentioned, the design of our platform means our supply side is inherently unstable. They can withdraw at any time. And the demand from our demand side is like a large pool. They want an endless supply of computing power from us that can be turned on and off and used at will, just like water and electricity. So how do we balance the extreme instability of the supply side and the extreme stability of the demand side? It's done through our intermediate scheduling system. So some of the barriers we've built in the short term are based on our technical explorations. As for resource integration, it's also quite important. And for hardware management capabilities, we're basically at the same level as public cloud vendors right now.
In my understanding, for your company, when dealing with heterogeneous resources such as GPUs, CPUs, bandwidth, and storage, what is the biggest technical challenge? And how do you achieve high utilization and low latency? Because I believe that for users, latency is a big issue.
Yes, that's right. This is how we handle it. Because we are also exploring, we certainly can't demand perfection from a cloud computing company that has only been established for 2 or 3 years, and our team is probably only a few dozen people. So on one hand, there are some technical difficulties that we have tackled head-on, On the other hand, our approach is to choose specific scenarios that are suitable for us to work on, rather than choosing to handle all scenarios. Specifically, our platform does have GPUs, CPUs, and resources like bandwidth and storage, which have recently been called general computing resources, but our main focus is on the supply of GPUs. The supply of CPUs is just to facilitate our GPU customers, as they occasionally use CPU resources, so there is a ratio. The biggest technical challenge we've encountered is actually the biggest technical challenge in cloud computing, but it's even more demanding in our architecture. It's mainly two things. One is stability, and the other is security. Both users and suppliers will ask you about these two issues. Our challenge with stability is greater than that of cloud vendors because the physical resources are not ours, so we have to bear more unpredictable risks from the supply side. And our challenge with security is greater than that of cloud vendors, also because the physical resources are not ours. So we have to bear the risk that data from both the supply and demand sides could be lost or stolen during transit. Regarding security, we've chosen to tackle it head-on, because if we don't crack this nut, we might not be able to build a truly large-scale market in the long run. So we actually have a dedicated security R&D team that has been continuously conducting research over the past 2 or 3 years to ensure the security of data storage, transmission, and so on. As for stability, Stephen, you also asked how to achieve high utilization and low latency. For high utilization, it's based on our self-developed scheduling platform and algorithms. We have done very fine-grained operations and even used some AI algorithms to make dynamic predictions based on past data. This allows us to maximize operational efficiency, and we are constantly pushing our algorithms, hoping to squeeze them as much as possible. As for low latency, our choice is actually to avoid certain scenarios. We haven't tried to tackle the low latency challenge head-on, because things like the network or global terrestrial latency really require a huge amount of resources to be invested. For example, a company like Cloudflare, I think they probably have a team of at least hundreds or thousands of people just focusing on latency. We don't have that kind of manpower or financial resources right now. So, our current choice is to select some scenarios that are relatively less sensitive to latency to serve first. Fortunately, in this wave of AI, a batch of scenarios that are not so sensitive to latency has emerged. These scenarios are mainly multimodal inference, which includes the generation of a lot of multimodal data. This includes video synthesis, audio generation, and image generation. Because their computation time is already on the order of seconds, for example, it takes a few seconds or tens of seconds, these models' inference already takes that amount of time. So whether the latency is an extra 100 milliseconds or 200 milliseconds, users can't feel it. In typical scenarios like making a phone call or having a conversation, a 200 millisecond delay, or in gaming, is indeed very critical. But in these emerging AI scenarios, this part is actually not that sensitive. Therefore, we also chose to first vertically penetrate the scenario and capture this part of the market first.
You've just answered my next question. I was about to ask if there are any AI algorithms to dynamically optimize the scheduling of computing power. There's a saying now, is it possible in the future for AI, for example an LLM, to schedule AI resources like hardware so that humans no longer need to manage it? Perhaps there might be such a direction in the future. Let's now talk about the industry and the market. Our technology is already well arranged, and I believe the product will get better and better. But let's go back to the overall landscape of the Chinese computing power market. What are your current views, and how does it compare to overseas? For example, we generally know about companies like AWS and also CoreWeave. What are China's advantages in computing power infrastructure?
China's advantages are quite obvious. There are two distinct points. One is that China's energy infrastructure is really excellent. In the context of computing power, we can already see that the energy supply in the United States is often in shortage due to large-scale inference clusters. But in China, energy is often considered a solved problem. We haven't had situations where AI clusters couldn't run due to insufficient power. It's usually for other reasons. So I think one of China's advantages and a long-term strength that China can continue to build on is the energy side. The energy side definitely has an advantage. And in the process of diminishing marginal costs for hardware, more and more of the cost of AI will gradually shift to the energy side.
Perhaps right now, when we use AI, out of 10 cents of cost, 9 cents come from hardware amortization and 1 cent from electricity. Of course, I'm not counting R&D costs. But perhaps gradually in a few years, it might be half from hardware amortization and half from electricity. Maybe in a few more years, with the emergence of specialized chips, the cost of inference can be further reduced. Then maybe hardware will account for 1 cent and electricity for 9 cents. So I think one of China's advantages is in energy. The second advantage, I think, is that China's manufacturing and scale effects are still very powerful. So although in both the CPU and GPU fields, China has been limited because its foundation in photolithography is not deep enough, in the upcoming wave of AI, it's actually a very good time to use industrial scale effects and a mature industrial manufacturing system to overtake others. Because our demand for GPUs, or rather for their manufacturing process and technology, is actually decreasing. Our current GPUs, unlike previous CPUs, don't need to serve many general-purpose functions. That is, general-purpose computing. It might serve a specific type of computing, for example, just inference. But a CPU needs to handle all kinds of functions. It needs to have these capabilities. Secondly, our research in AI has also found that the precision of large AI model inference is also decreasing. It might go from, for example, double precision floating point numbers to single precision, and now even down to FP4 or INT4, and it can still run very well. And this way, the difficulty of the manufacturing process and chip design is also decreasing. So China can totally use this opportunity to manufacture very useful and very low-cost specialized inference chips. And then, by leveraging China's energy dividend, I think this is China's advantage. Thank you for your sharing. It was very comprehensive. Now, let's answer a question. The explosion of large models in the past 2 years has brought about a shortage of computing power. Given this shortage, how did you find your positioning in an environment of tight supply and demand? Well, this is quite interesting. Everyone sees a shortage of computing power, but often there is no shortage. It's just that people don't know how to find it. For example, when we first started our business, we made a product called Swan Lemi, which was a play on the name of a Chinese food delivery brand called Lemi. It actually collected the computing power resources from high-end graphics cards of gamers. For example, the 4090 and the current 5090. In fact, NVIDIA's shipments in China are very high. According to Steam statistics, just last year in China, there were 300,000 RTX 4090s used for gaming. So the shortage we see in the AI field may not be a shortage in all fields. So our strategy is to import the non-scarce resources from other fields. For example, these gamers who might only play games 1 or 2 days a week. This is a very huge resource, and we direct it to the AI field. And in the past 2 years, I don't think the AI computing power in the Chinese market has been in short supply. Because with the explosion of AI, major manufacturers and even some investment institutions have treated the construction of AI computing data centers as a capital investment activity. So it hasn't been a very short supply. So, who are the main users of Gongji Computing Power now? I saw on your website that you might serve AI startups and research institutions. Are there any digital transformation scenarios in traditional industries that also use your products? Yes, there are. Our users, as I briefly mentioned when talking about our demand side, are actually very simple. It's people who need to use elastic computing resources. To elaborate further, it's those whose computing power needs face uncertainty. Because as long as the computing power demand is certain, they can always find stable computing resources. As for the uncertain ones, we generally serve 3 types of customers. Our first type of customer focuses on those multimodal AI inference application vendors. Some of them are startups, some may be more mature, whether it's because their customer base is an unknown number, because being a startup, or because they're already mature but their business fluctuates over time, there will be a period where they need to use elastic computing power. So we undertake their services for this part. The second category is serving those vendors or individuals who need to do data processing and some asynchronous computing tasks. Because data processing in these asynchronous computing tasks, like batch generating things or batch labeling or cleaning things, are like planting and harvesting. Therefore, their demand for low latency is also very small. It happens to fall into the area we're good at. And such a projects often face unpredictability. Usually a project team is formed within a company, and they want to train a model. Only then do they start preparing the data. The current embodied intelligence scenario is also like this. So it's also very difficult to find a large data center in a short period of time that they can use, and that they can release without cost immediately after use. Currently, you probably can't find one. So using us is quite suitable. And the third category is in the education and research scenarios in universities. Because whether it's a lab doing an AI-type project or hundreds of people taking an AI class together in a classroom where everyone needs an AI learning environment, it's all a fluctuating demand. Maybe they only have a class for 2 hours a week, or maybe your lab suddenly needs to use it for a few hours a month. And some traditional industries we've observed, whether in manufacturing or services, they all have a need to transition to AI. In the process of transitioning to AI, they'll naturally come into contact with AI and computing power. So, we also serve some of these traditional vendors.
Now let's talk about risks and strategies. You mentioned the current international environment, the US chip export restrictions, and the uncertainty in the domestic GPU replacement process. These all pose challenges for a computing power platform. How are you currently, or how will you in the future, manage supply chain risks?
Actually, I think if you look at this problem on a 5 to 10-year scale, it will become a small problem. Because I believe that in about 5 years, China should be able to produce pretty good chips, especially in these specialized scenarios. However, in the recent 1 to 3 years, or 3 to 5 years, we do face such a risk. On the one hand, the export ban on high-end graphics cards from the US to China is becoming stricter. On the other hand, China's own chip ecosystem has not yet matured. It's not just the hardware ecosystem. It also includes the software ecosystem, which hasn't matured either. In this situation, it might be a transitional period where the old is not gone and the new has not yet arrived. So the method we adopt is probably to make good use of the existing stock and then strive to create some new supply. The existing stock in China is actually quite large. Whether it's in the gaming sector, you can find a lot to tap into from internet cafes and individuals. And secondly, the number of chips that have been imported into China in the past few years is actually quite substantial. So it's possible, for example, the DeepSeek team has often proven that you can train a very powerful model with just $1 million or less. It's possible that this demand can be handled with more fine-grained operations. And in terms of creating new supply, we might also focus more on promoting the globalization of our platform. Maybe our platform doesn't necessarily use computing power from North America right now, but our next step might be to use it from places like Hong Kong, Southeast Asia, Singapore, or even the Middle East. We will consider both its computing power supply and demand. We might also come to Europe to explore such attempts.
A self-reliant and controllable computing power ecosystem will eventually be established in China, and Gongji Computing Power, in a macro sense, will always play the role of a resource scheduler and allocator. Let's look at future trends now. Small models, especially SLMs, small language models, are not yet mainstream, but we see many labs working on them, and they are also being deployed and tested on edge devices. In the future, if small models become mainstream, will it have an impact on centralized computing power platforms? And how do you view the contrasting trend between data centers and edge device deployment?
Well, actually, we are happy to see such a trend. For example, one of our top clients in the industry is from Tsinghua, called Model Best. They specialize in making small models. Actually, Stephen's question can be summarized as a prediction about the future direction of AI on the edge versus in the cloud. I think so. First, if the trend of model miniaturization becomes stronger. For example, we also see that models have a density theorem, which says that the capability of a model doubles every, say, 18 months. That is, a model with the same number of parameters will have double the intelligence, or a model with the same intelligence will have half the number of parameters. This trend has actually been accelerating recently. Why did I say we are happy to see this? Because what we as a platform hope for is not for the cloud to monopolize everything or for everything to be on the edge. Because we are a platform, we just give some unused computing power to another part for use. If everything is in the cloud, that means all the market share is held by those who build their own computing facilities. If everything is on the edge, then indeed no one will use cloud services, and the service side we provide will not be viable. But the development of small models will lead to a considerable number of people, whether because of the model's capability or the privacy of their own data, will definitely purchase some devices with edge computing capabilities. And as we just concluded, whoever buys a computing device, there will definitely be times when it's not used to its full potential. There will definitely be times when it's not fully utilized. So we will definitely have the opportunity to extract a part of its computing power and then use it to serve other people with similar needs. So I said we are quite happy to see the implementation of these medium-sized or even small models. If, on the contrary, it's a future where only super large models can dominate, then their inference might all be placed in specialized super large data centers, with their own custom-designed architectures and even self-developed chips. In that case, there might not be any opportunity for a very small team like ours.
Since we mentioned small models, let's now talk about open source models. I remember watching a video a few years ago where Robin Lee said that making open source models is meaningless. I remember he said it's not a closed loop commercially. How do you view the commercial potential of open source models now? And can computing power platforms also leverage the open source ecosystem to create new growth points?
First of all, I think Robin Lai's point of view is intuitive and aligns with common sense, which is why he said it. I think most people probably don't understand why they would open source what they've developed. What is the business logic behind it? How do they recover their costs? Many people understand even less, for example, why DeepSeek does everything open source. And they might not understand why most companies in the US are now closed source models, while in China, almost all the top major companies are doing open source. I think it's like this. Because we've only been doing AI for a few years, we might only have some superficial thoughts. First, I think that in the current era of AI, the barrier to our technology is actually lowering. That is to say, in the AI era, to master the most cutting-edge technology, such as training a super large model, the requirements for team building, system complexity, and the knowledge reserve you need, compared to building, say, an Airbus, a large airplane, or a highly precise system, or making chips, or making mobile phones, it's very shallow or thin in comparison. Because everyone's data is basically obtained from the public domain, some people might have their own data sources, like Google has YouTube and ByteDance has Douyin. But if you don't have such resources, even OpenAI can probably only get it from the public domain. The second point is that the algorithms are constantly being researched and published in academia. And even if you have a closed-source business model or a trade secret, the algorithm can be completely taken out by a small team leaving your company and being hired by someone else. We all know that California doesn't have non-compete agreements anymore, right? This transfer window has become a transfer window model. It could be completely brought out by the departure of a small team. Whereas in the past, even if I was building a Boeing 747, even if a team of engineers left, they couldn't just start another company and begin building large airplanes from scratch. Therefore, its system complexity is actually decreasing. And the third part is computing power. This matter is currently in a state of collaboration, and the current computing equipment is also general purpose. So it's not the case that you can only train a large model if you have very good computing equipment that others don't have. That's not the case either. So I think the core point is that in this era, the technical barrier for AI models has become lower, not higher. That is to say, the layer where technology creates value has become thinner, not thicker. Including if you do closed source, even if you do, others will replicate you in a year or two, maybe even less than a year. So everyone will do open source, because even if you don't, in a year or two, others will have something better. And when you do closed source, you actually create a competitive advantage for latecomers. For example, because you're a closed source, your model has a fee. Then a latecomer can make a model that is almost as good and charge a lower fee, or they can go open source. So I think this is the basic logic of why there is open source in this era. That's how it is. Of course, this is just my superficial understanding and what I've learned from some of my seniors. Now, why is there so much open source in China, while in foreign countries, North America is now mostly trending towards closed source? I think it's probably because everyone's business models are not that similar. Perhaps in North America, it's a typical process of converting technology into commercial value, whereas in China, either this process has very thin profits and the AI market is smaller, or on the other hand, Chinese people are just very smart. So I think in China, everyone will go the open source route. So I think their business logic for going open source, in my speculation, is probably to exchange it for their brand traffic and business in other areas and then earn it back through that. For example, Alibaba has done particularly well in this wave. Their Tsinghua model, I believe, is widely used by most research teams and AI application teams, whether in China, the US, or Europe. Then they can go on to promote their self-developed chips that have good compatibility with Tsinghua, or they can promote their Alibaba Cloud services that have good compatibility. The R&D expenses for Tsinghua are actually negligible. They can completely recoup it in other areas, for example, through Alibaba Cloud's entire global business. As for companies like DeepSeek or some others, I think they might be converting this part of open sourcing into brand awareness and traffic. Of course, I believe that for someone like Liu Wenfeng of DeepSeek, he might genuinely not care about any intermediate products, so he just open sourced it. So its brand is probably an added value. But for the strategy of some companies like the current Kimi and maybe Meituan, which is just starting, and perhaps Tencent, they might be using their own models open sourcing as a measure to gain brand awareness and to secure a place in the future ecosystem, right? It's a bit like issuing a currency. Stephen is surely an expert. If your currency system is issued in a very closed manner with low circulation, your pricing power and ability to regulate it in the future market will be limited. So I think the basic logic is probably like this.
That's extremely well said. You've covered all the details. And it feels like OpenAI was also forced by this open source wave in China to open source its models, and now they are very anxious, both in terms of the frequency and speed of releasing models, and also they now want to take things that are already doing well in research, like agentic workflows and orchestration, and bring them onto their own platform. But recently, I've seen a lot of negative comments on social media saying that OpenAI is not doing a good job with these things.
Oh, like their agent kit, right? And also the external apps it connects to. Now it can interact with those apps, and people have also noticed issues like data privacy and personalized user management. It's all very interesting. Right, actually, when a model is finally released, as long as it's available to the market, you can obtain all of its capabilities and cognition by conversing with it. So even if it's closed source, you might be able to obtain most of its capabilities by cleaning the data. This process is generally called distillation. So I guess that some of the major companies in North America, if they purely go closed source route, their most core, end-of-the-line large model with an extremely large number of parameters, they probably won't even use it to provide services to the public. They will likely first perform an information compression from it to create a slightly inferior, smaller model to provide services to everyone. It's possible that's the case. The last question is, looking forward 3 to 5 years, when people mention Gongji Computing Power, what do you hope they think of first? I think it's elasticity. We have a small slogan ourselves, which is, for elastic computing power, find Gongji. And how do we evaluate the progress of our brand building? It's when people mention elastic computing power or elasticity, they think of Gongji. And when they mention Gongji, they think of elasticity. If we can achieve that, that would be okay.
Thank you very much, Adam, for your sharing. It was truly brilliant. We talked a lot. I hope Gongji does better and better, and you and your team members are always welcome to come back to my show to share with everyone. This episode of the podcast ends here. Thank you, Adam.
Okay, thank you, Stephen.
Stephen Data Talk.